Hello all. Today, let's welcome to this talk on accessibility and localization. So today, we'll be looking into how we can enhance our app experience using accessibility and localization. Uh, to start with my introduction, so hello all. I stay in India. I'm currently working at Paytm Money as an engineer. I love traveling and exploring new places. And you can also connect to me on my Twitter handle, which is mentioned on the slide. So let's begin. As we know that we Apple has provided us with an excellent support for accessibility and localization through various technologies like voiceover, voice control, and also for dynamic type sizing and all. So today we will be looking at different accessibility APIs and the support which the Apple has provided us. We will be working on making custom controls accessible. Also, we will be seeing that how the views which are having children along with them, how we can make them accessible so that we are having an overall enhanced user experience, and the user won't have to go on to individual children if we can make the experience better by combining all the children elements into a common accessibility element. In the end, we will be looking into localization and pluralization of the content that we are displaying into our application. So let's start. uh, let's start with Xcode 13. So with Xcode 13, we have a new accessibility panel which has been introduced to us on the right hand side. So when we click on that accessibility panel, we can see all the accessibility elements that are there in our view. So let's say here I'm showing a checkbox label view in the presentation slide. And inside the body, we have created an H stack which is having three elements. One is the image, text, and one is the image, and we have two text labels. Now when we look at the accessibility elements here, so we can see that we have these three accessibility elements with us, and along with the accessibility along with the details that we can see in this panel, we have label, value, identifier, and traits. So Swift UI views take the data for accessibility elements from when the Swift UI views are initialized. So here I'm using an SF symbol for the image. Like here, as we can see, we are having a checkbox icon out here. So this is the SF symbol image which I'm using, and the name for that SF symbol image is checkmark rectangle dot fill. And when the checkbox is not checked, we are using just the rectangle. So based on the SF symbol image, the label associated with it is checkmark dot rectangle dot fill. So like even while developing, when you are viewing your Swift UI views in your preview, you can view the accessibility elements that are there in your view, and you can manipulate them or maybe change them based on your requirement. So for a very simple view like this, as we can see, we have three accessibility elements. For text element, as we have seen that there is some label associated with the SF symbol. Similarly, for the text element as well, we have some label associated with it. The label is the text or the value which we are providing to this element. So here I am providing some title to it. In my case, the title which I am passing is extra cheese. So the label is also extra cheese. And because this element is not is does not has any user interaction enabled, so we are having the trait as is static text. So let's move ahead and see what we are going to do today in this session. So I have created a demo application out here. So this is the demo application which allows the user to order food. We have provided different options to the user. The user can select extra toppings. They can select the size of the pizza they want to enter. They can even wish list any items they really like and they order frequently. They can view the item price and also few of the item details, like whether the item is vegetarian or some other properties about that item, like if it's a bestseller or not. So let's see how is the accessibility behavior of the application in current state.
Voiceover on. Order food. Order history. Button. Order food. Heading. Mexican wave. Add to place order. Vegetarian. Bestseller. Pizza. Indian rupee sign 160.00. 4.0 stars. Given by 621 customers. 0. Button. Adjustable. Swipe up or down with one finger to adjust the value. Screen recording.
So, in this video, we just saw how the app is behaving when we have enabled the voiceover for this application. If you have been listening to the recording which I just played, you must have noticed that we are first going through the Mexican wave title, which is fine, but then the order for the tags or the other elements which are being spoken by the accessibility element might not be very clear to the user, like which element is being referred to for a given title. Like the accessibility reader spoke the add item to the basket in between only, so and a few of the UI components later on, which might be confusing for the user, like what action the user would be performing when they double tap on the selected item. So let's start by making this app more accessible and more intuitive to the user, so that they are able to navigate through the application in a very convenient way. So I'll be starting with a bottom up approach. In the bottom up approach, I will be covering different elements which are shown on the UI. Uh, we'll be starting with the tags element, then we'll be going on to the details, and then towards the rating and towards the like button. With this, ultimately, we will be seeing how our app has enhanced the accessibility behavior and how users would be interacting with it later on. So let's start. So I'll be starting with the tags view. So as we can see, the tags view has two elements with it. We have initially we have an image which is depicting whether the item is a vegetarian or a non-vegetarian item. Sorry.
It's okay.
Okay.
Nothing. Yeah.
Um, okay, so let's see. So here we have a tags view, and in this tags view we have two elements. The first element is telling the user whether the item is a vegetarian or a non-vegetarian item, and the next thing is the other tag, which is providing the user the information if the item is a bestseller or not. So for this simple view, let's see what are the accessibility elements we have currently. So for this element, because it is an image with a circle, so the label associated with it by default is circle. And the next accessibility element which we have is the bestseller. And inside this, because this is a text element, we have the label associated with it, which we are passing as its string. So here the label is bestseller, but for this SF symbol image, it is not providing correct information to the user, like what information is being depicted by this image. So let's move ahead and try to make this small UI component accessible. So also, if we look at the accessibility tree of this view, so in the tags view we have two elements. One is the image and the other one is the text pixel. Moving ahead, what I have done is I have added an accessibility representation to this view. What does accessibility representation do? So it is an API provided to us by Apple in Swift, which ignores the accessibility elements that are provided by the view, and instead we can provide our own custom accessibility elements to it. So inside the accessibility representation, I am creating an edge tag and I'm providing different text labels to this. So if the item is vegetarian, I'm creating a label with a string vegetarian, and if it's not, then I'm creating a text with a string of non-vegetarian. Similarly, if the item is a bestseller, I will be associating the text with bestseller label. So if we see on to the accessibility elements now, we will see that we have two accessibility elements which we had earlier as well, but now the label of the accessibility element of the first element is now changed. Earlier it was circle. Now it has changed to vegetarian, which is correct, because now the accessibility representation is taking the item to be a text instead of an image. So now we are getting the correct label of vegetarian, and because it is not user interactable, we are keeping it straight to be static text. Similarly for the other element as well. This way we have made our tags view to be accessible and providing the correct information to the user, like what information is being displayed by the tags for a given item. So let's move ahead. Also, when we see the accessibility tree of the changed element, we can see we now have both the elements as text instead of the earlier case where first element was an image. Now we move ahead and we try to make this view accessible. So here I am adding my tags view at the first level. Then I'm adding a title to this details view, which is the Mexican wave, and then I have a vertical stack. In the vertical stack, I have added two labels. These two labels have some image associated with them. If we look at the accessibility tree out here, so we have these five elements laid out in the accessibility tree. These all five elements are individual accessibility elements. They have their own label, they have their own traits associated with them. So if we see the tags view, which we just saw, we for which we corrected the accessibility, we now have vegetarian and bestseller. The other three elements which we see are Mexican wave, pizza, and 160. What we'll see that the accessibility elements for the label with image are just having the label and no information about the image. That is because when an image because in a label component, if we are having an image, it's accessible, it will not be an accessibility element. The only accessibility element would be the text which is associated with that label. So even if you try to make this image accessible, it would be ignored by the accessibility reader. So leaving us with only five accessible elements. Now the issue that we saw in our accessibility reader was the tags vegetarian and bestseller were being read earlier to the title of the item itself. So how can we fix it? What exactly is the requirement? It would be really great if Mexican wave can be spoken prior to the tags view so that the user knows that the tags are associated with a certain title. So let's go ahead and fix this ordering. What we can do is we can use a accessibility sort priority. Accessibility sort priority is another API which is provided to us in Swift, which helps us in defining the order in which the accessibility reader goes through the accessibility elements. Here we are associating the accessibility sort priority with the title, which is Mexican wave. Because we have added a sort priority of 1, Mexican wave will take the first place in the accessibility tree hierarchy. By default, the sort priority of all other elements would be 0, and the sort priority for the element with the highest number would take precedence over the others. So because of this reason, Mexican wave will be the first one to be traversed in the accessibility hierarchy. Then comes the other views which we have. For till this point as well, we have all the accessibility elements in their individual self. They are not linked with each other. They have their own accessibility labels and their own traits. But when we are assigning accessibility sort priority to this view would be ultimately treated as a subview inside some other super view. So we don't want the accessibility sort priority to interrupt the accessibility behavior of our super view. So what we can do is we can combine this entire elements into a container. What will a container do? Let's see. I'll be using accessibility element children property for it. What does accessibility element children do? It is another API which is provided to us by Apple. So accessibility element children takes around three values which are .ignore, .contain and .combine. Both of these three values alter the way the accessibility container is created for a certain view. Like in this case, for a V stack, applying an accessibility element children contain to it, it will create a new container, and inside that container, it will encapsulate all the children accessibility elements inside it. So, when we will check the accessibility element for this container now, it will be having five elements inside it, but still the labels and the traits are still associated with the individual elements. We have just created a wrapper over the individual accessibility elements to create a container over it. Now whatever values which we have assigned to it inside the container, that is the sort priority, it would be limited to this container itself, and they won't interfere in any way with the sort priority for their super view. So let's move ahead and see like how this component would be behaving with the accessibility. But because these elements are still individual and not bind to each other, The user would have to right swipe with their finger on the device to move on to individual elements. We don't need that because all of these text values are just static text. We don't want the user to interact with any of these. So instead, we can combine all of these values to create a unified label which will be which will be providing us with the detailed information about this component. So let's move ahead and try to combine these values. So earlier we added a contains to it. The contains created an accessibility container with 5 elements. Now I'm adding and combine. I'm adding accessibility element children combine. So what does the combine API do? So combine API will modify the container which was created by the contain accessibility element, and it would instead combine all of these accessibility elements into a common accessibility element. So ultimately, when we will try to see the accessibility elements of this entire view, we will be having just one accessibility element, and it will be providing us with the detailed information of all of these accessibility elements in a common way. Let's see how it will look like. So after the sort priority, we created a accessibility tree with Mexican wave to be added at the first accessibility element. Next, if we see the accessibility element for it, still the elements are individual. We had Mexican wave, it has some traits associated with it, and also the sort priority. For all other elements, because the sort priority is by default 0, we are not getting to see them. But their accessibility traits are still visible. It is a static text, and we have some different labels associated with it. Now, after we have added the child behavior of contain, then we have created the accessibility container. Even in the Xcode, we can see now earlier what we were saying accessibility element, it has changed to accessibility container. And it only has 5 children associated with it, but no label associated with this particular container. Then if we click if we apply the combined behavior to this accessibility container, all of these accessibility elements are unified into a common accessibility element. And now this accessibility element will be having a label to be Mexican wave, vegetarian, bestseller, pizza, and a price associated with it. So with this, the user won't have to go on to the individual accessibility elements to navigate and know the information about them. They would just have to move their focus to this accessibility view, and it will provide the complete information about their children as well. So this was just one way how we have clubbed the children of the accessibility view inside a common accessibility element, which is providing us with the entire information that we need. The earlier API which we used, accessibility representation, so how is it different from the accessibility children? So accessibility representation eliminates the entire accessibility tree of the view. But with accessibility children, we are combining and enhancing the behavior of the view to combine or contain the elements inside it. So it is not altering the accessibility, it is basically enhancing and combining the elements inside the view, but not discarding them in a whole. So let's move ahead. Now we also saw that we had this rating scale on our card view, which was providing us with the rating, which is the average rating provided by the number of customers mentioned here. So here, if we look at this view, which is for now clubbed, which is not shown in full, but if I want to explain it to you, we have 5 stars out here, and these 5 stars are informing the user what is the rating of a given item. In this case, the rating is 4.5 stars, which is the average rating given to us by the 21 customers. To enhance the user experience, we want the user to know by getting the focus on this entire element what is the rating for it, instead of going on to the stars individually and going on to the count in the end, which might be confusing to the customer that these elements are related to each other. So without any accessibility trait added to this view initially, we will see that the accessibility elements of this view are individual image items, and in the end we have one label which is 21, which is for the text which we have. The text, in the text we are passing the string to be a count of the number of users which have given the rating to a certain item. So it is 21, but we don't have any text label associated with it. So the default behavior of this element would be favorite, 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 star leading, half filled, favorite and then 21, which is not providing much information to the user. So let's go ahead and try to make this view accessible. So now what I have done is I am using accessibility children API again, but now with the ignore parameter to it. What will ignore do? Like in the earlier case, we had these individual accessibility elements and they all were different. With the ignore parameter passed to the children, all of these individual elements would be ignored and this entire view would not be considered as an accessibility element. So if we just leave our code up to this point, the accessibility will not focus on this view at all because there are no accessibility children associated with it. But we want the view to be accessible. So what we can do is we can again use the accessibility representation API. In the representation API, I have created a edge stack. In the edge stack, I am providing some custom localized string to this view. Why we are using a localized string? So let's take an example and explain it. So let's say for an item which is having just a single star rating, we want that the view should be the accessibility reader should be reading it as 1 star because it's just a single star. But when for an item with the average rating of 4 stars, we want the accessibility reader to be reading it as 4 stars and not 4 star because we are having multiple stars for a certain item. So we want our accessibility label to be pluralized. Why does we want it to be pluralized? Because based on different language, the behavior how the accessibility reader reads out a certain string changes. Like for English, we have if we go further and look at the localization.strings dict, we can see that we have a string dictionary out here. In the string dictionary, we have this key which is the localized key, which we add inside our code to tell that this is the key which we want to localize. For a certain key, we need to associate it with a format. This is the format which is taking just a count. The count will be the rating which we are providing. Count is the number of users which have actually rated for a certain view. So here we are taking the format key to be in this way, which is just expecting a variable of named count. So now in this formatter, the variable is count, and this variable is the one which we have to consider while creating the accessibility string. So here we can see in the strings dict, we have these classes mentioned here. So which are 0, 1 and other. So this is the localization string dict for English language. So in English language, for singulars, only 0 and 1 will be used, but for plural localizations, other will be used. Like for the case for 4 stars, we will be landing into this class, which is the other. Similarly, for other languages, let's say for Arabic, we won't just have these three classes with us. We will be having different classes. We will be having classes for few, we will be having classes for many. Even based on that language, the text also would be changing. So we don't want to add these conditional code inside the view file to handle all of these scenarios. We want the localization to be handling this, which is the expected behavior as well. So we have created a localization string dict file, which is having this entire structure. Similarly, this is the localized key for customers count. Similarly, this is the localized key for rating star. Because rating star is a floating point value, we are taking a C type value specifier to represent that the value which we are passing to this formatter key is of type float. Similarly, we are adding different classes to it. Like for 0, we are adding no rating. For 1, we wanted to read it as 1 star. Similarly, for other, we wanted to read it as whatever is the value of the rating we have provided, followed by stars, because this is a plural value. So with this implementation done, if we go on to our code again, we will see that the key which we have added in the localization string dict, we have added inside this localized string. We have also added a comment to it because later on, if we try to export the localization of a certain project, these comments would help the translator who would be helping us with the localization in other languages to understand what is the context of a certain key, so that they would be able to add the correct localization for a certain key. Here also, so this is the localization string for rating stars. Similarly, we also saw we had a customers count. So for that customers count as well, I have associated it with a comment which is informing the translator correctly that this is the count of customers that have provided a certain rating, and this has to be a part of string dict. Also, once I formatted a certain string, I am passing it to the text along with the variable which I want the string dict to be considered. Like here, I am passing a count to it. The count is the number of customers who have given rating for a certain item, and here I am passing it a rating, and this is the rating which will be actually used inside the localization string dict to consider if the rating is a plural or a singular one. So this is the string file for the English localization. Now, once we have done this localization, let's see what is the accessibility element for our view. Now, if we consider this view, which is having 4.5 stars given by 21 customers, our accessibility element would provide us with something like this information, which is telling us that the customer or a certain item is having 4.5 stars given by 21 customers. Similarly, for this view, we are just having the label as 1 star given by 21 customers. So for this implementation, we just had to ignore the accessibility element of the entire view, which were the individual image labels and also the text which is there. Instead of that, we have created an accessibility representation, which is a horizontal stack of two text labels. Now, uh, because we have been using accessibility representation for two of our views, why exactly are we using accessibility representation? So this is an ideal and also a recommended approach to provide accessibility for our custom views. So adding a custom behavior to our custom views can be done really easily with the accessibility representation. Also, this API provides us with a lot of flexibility and possibility to provide a customized behavior to our customers for a certain view. So, if we move ahead, we saw the localization string dict for an English language. Now, if we look at the localization string dict for Hindi language, Hindi is a language which is used in India. So, the entire structure of the localization string dict remains the same, but the values of the classes which we have mentioned here have changed. For English, it was a different. Being a different language, we had some different language for it, different values for it. But for Hindi, we have provided the Hindi localization for it. So when our accessibility inspector would be going through the application for a device which is having Hindi localization, it would be taking the localization strings from the localization.strings dict. Here we have been using localization.strings dict. We also have a file localization.strings. So what is the difference between these two files? We should be using localization.strings when the accessibility strings don't have a value associated with them, like they don't have a count associated in them based on which the accessibility string changes. If we want a certain string with a count associated with it, and we also want it to be pluralized, we should be using localizable.strings dict. Also, one point to note is that the name of the localization strings dict and the name of the strings file should be same. So here, if I'm having a string dict with the name of localizable, please ensure that your .strings file is also having the same name. Internally, Xcode will manage and combine both of these files to create an xclog file, which would be ultimately shared with the translators for translating or scaling your app for different localization. Also, as we have seen that we have these different localization keys here, we should also ensure that these localization keys are unique among themselves. For example, if we take a label like clear, so this clear can be associated with multiple contexts, like it can be used with a text field to clear the text. It can also be used in some other context where it might be providing some different information to the user. So having different unique keys for the localization keys, it would be easy for the translator, and even within your application you would be easily able to identify in what scenario which key is being used, and there won't be any ambiguity while at the time of translating or scaling a given application for a different language. So this was about how we can use localizable.stringsdict and .strings file in our project to provide an accessibility and also the accessibility support with a given localization. So if we move ahead, we also had this like item in our card view. So this like item, I have used SF image for this. As we discussed earlier, SF image is having some label associated with it. Because the SF symbol which I am using here is heart.fill and heart, the accessibility label by default which is associated with this element is love, which is not providing much information to the user in our context. So what we can do is we can modify this behavior as well so that it provides some useful information to the user while they are trying to interact with this element. Also, as we saw in the video, this element is tappable. We have a tap gesture added to this. So when the user clicks on it, the icon changes to a state where it is not filled. So basically this element is tappable, but the traits which are associated with this element is image. So the accessibility reader would not provide the user this information that this is a button. So let's move ahead and add all of these traits to this. So to start with, I'll add an accessibility label to this element. Adding an accessibility label to an image will modify the image label to take something which is providing more context to a certain element. Like here, if the item is liked, I am using the accessibility string as item liked. Similarly, if the item is not liked, I'm informing the user about like they can tap on the given button to add it to favorites. So this is providing more context to the user. Also we can see it also when you will be creating this view inside your Xcode, when and try to inspect the element, you can see this that the traits which are associated with this certain view are also now changed. Earlier it was providing us the label of love, but now it is providing us with item liked and double tap to add to favorites, which is providing more context to the user. Moving ahead, I'm also providing an accessibility identifier to this view. Accessibility identifier will be used when you're trying to add the UI test for a certain component which is intractable. So with this accessibility identifier added, we can easily identify this given view inside a view hierarchy and tap on it or apply any kind of interaction on it when we are trying to do UI testing. Also, moving ahead, we can add, because earlier it was having an trait of dot is image, it was not providing the user the information that it is tappable and it is behaving like a button. So what we are using is we have added an accessibility add traits to this view, and the trait which is added is button. So now the traits in the accessibility panel as well will be changing to the updated values, which is button instead of is image. Also, because now this element would be behaving as a button, having an accessibility trait of is image won't add much useful information to it. So we can remove the unused trait from this element, and we can just say accessibility element remove traits dot is image. So now the final accessibility element which we'll be having for this view is what we can see here. It will be having a label of item liked, it will be having an identifier associated with it, and it will also be having the correct traits which you need, which is button. So in this way we have made all our subviews accessible inside our view hierarchy. So now let's see what will be the behavior of our app after we have applied all of these changes. So let's see first in English.
Voiceover on. Order food. Order history. Button. Order food. Heading. Mexican wave. Add to place order. Vegetarian. Bestseller. Pizza. Indian rupee sign 160.00. 4.0 stars. Given by 621 customers. 0. Button. Adjustable. Swipe up or down with one finger to adjust the value. Screen recording. Order food. खाना मंगाओ. Heading. Mexican wave. शाकाहारी. सर्वश्रेष्ठ विक्रेता. पिज्जा. भारतीय रुपए का चिन्ह 107.00 4.0 621 ग्राहकों द्वारा दिया गया. जोड़े गए. 2 बटन. एडजस्ट करने योग्य. मान 3 4. अंतिम आदेश तिथि 28 मई 2021. अतिरिक्त टॉपिंग का चयन करें. चयनित. अतिरिक्त चीज. भारतीय रुपए का चिन्ह 50.00. स्क्रीन रिकॉर्ड.
So we have seen our app is accessible with both of the given localizations, English and Hindi as well. Also, all the accessibility elements which we have modified are now behaving as expected. We are first navigating onto the title of our item and then going on to the individual tags, which is providing the correct information to the user as well that these elements are associated, and in the end if they will be interacting with a certain element the action would be performed related to a certain title. So that's all from my side. If we have any questions we can take it up.
Okay, thank you so much, Priya.